So uh, every connection has been made, and every communication also has been established. From the RCC we can see that. So now I am going to turn on the charge controller using this RCC control. You can see that. Hello everyone, I'm Suraj from Leh Helios. Today I'm going to take you to a video where we have done a hybrid solar projects. In this particular location, there was an on-grid system. Now we have converted that system to a hybrid system. So this is a mansion actually. So they are consuming around 100 to 120 units per day, and they were also using a generator. Come around, I'll show you the generator. So due to some reasons here, most of the time the grid was not stable, so the system was not able to provide an pure power because of the input is not was not correct. So they were using this generator. It's just 25 kVA generator here. What you can see behind me is a generator customer used along with the on-grid system before they going with the Studer system. Currently it is not functional. They have dismantled this one, so it's a dummy right now. So this is the use. If you are using a hybrid system, we can remove that generator at times. And like if the energy requirement is so high, we can also couple this generator as well with the system, and there are many things we can do the with the system. So anyways, currently the requirement at this particular house, they are using around 100 to 120 units per day, and with this setup it is sufficient, and it's almost 1 month they are not running this generator for. So we can have different protocols, different parameters, and different setups for each project. So you can take this project as a reference. See, there are commercial establishments, they are using almost 100 and 150 units per day. They can also use this particular system to get their uninterrupted power. Your requirement is so high. In that time, we can also couple this particular generator with this setup. So every hybrid project is a tailor-made setup, and it's a professional task. So that is why it is very important you should have the system installed from a people who knows how and what they are doing, because there are many parameters regarding the if it is a the capacity of the inverter, or a PV capacity of the PV, or the selection of the batteries, everything. There are so many parameters we have to understand before before we conclude with the design of the system. So that is why we are into the hybrid system design for last 6 years, and that is why we are able to do this and accomplish this task in flying colors. If you wanted to have an uninterrupted power at your location, do let us know, and we will give you a tailor-made solution for you. Okay? And the energy requirement here is huge, because they are having many equipments here. Many they are having 2-3 ponds for fishes. There are some exotic fishes are there, and there is a VRF AC also there, and there are many delicate instruments inside the house. So they wanted to have a clear power. In this house, they are also using a one EV. I believe it's an MG EV they are using currently, and they do have a 3-phase charger also. So after the installation, even the power is not, even the grid is not available. Without turning on the generator, they can use they can charge their EVs with this hybrid setup what we have installed right now. And I'll also show you how this charges and everything. But the vehicles are not here anymore because the customer have went out. So I will show you the charger. So they are using this charger. It's a 7 kilowatt charger. It's from MG actually, charge mode. So they are using right now. Even the grid is not available from the hybrid setup. During the daytime they can charge the EVs. It's a 7 kilowatt charger. The reason why we have used a Studer inverter here is because of the modular topology they have to like upgrade the systems. Even if a customer is having later on, if the customer is having more loads in any of the phases, they can add one more inverter, and they can add the capacity also. So currently we have used 6 VT80 charging controller and 6 XTM 4000 VA inverter in this particular project, and there is a 30 kilowatt hour battery. So currently we have given this like hybrid topology. So ever since we have installed and commissioned the system, the customer didn't face any power cuts, and they didn't even use that generator since that they have commissioned this system. So I will show you around how the system is working and how neatly we have done the installation. So we'll go to the video. So energy is going to be very expensive since we are adopting new technologies, and the technological advancement and the power consumption is proportional. So, and just with the on-grid system or grid-tie system, it is not possible to cater the energy requirements. That is why everywhere in the world, everyone is adopting a hybrid system, either with a low voltage system or a high voltage system. Currently, we have used a low voltage, high frequency inverter with a galvanic isolation transformer. The reason why we use that thing is that because of the power quality. Studer is there in the market for 37 years, and this particular inverter is very good for a good power output. So we are using 6 number of extender 4000 VA inverters. Due to the R phase, 2 to the Y phase, and 2 to the B phase. So together it is delivering a power of 24 kilowatt, and we are also using a 30 kilowatt hour lithium ferrophosphate battery from Spider. One pack is 15 kilowatt hour, and it is having a 8,000 cycle. And this battery is compatible with Studer, and that is why we are using this particular battery. So as you can see 6 numbers of charging controller, and we are using 3 different kind of modules with this project. We are also using poly crystalline panels. The total number of panels is 53. So in the 4 charging controllers, we are using 53 numbers of polycrystalline panels. In there, there are different kinds of watt peaks available. So in the first charging controller what we are using, we will be adding 15 panels of 335 watt peak, and 3 of the charging controllers having the same capacity with the 15 kilowatt hour. The combination will be 3 in parallel and 5 in 3 in series and 5 in parallel. And fourth one will be having 6 solar panels. It is having a 385 watt peak solar modules, and other 2 will be having 550 watt peak of 10 each panels. So the combination will be 2 in series and 5 in parallel. So we are also using an AGB, which you can see in the video later on when I am showing the solar modules. Why we are using this Studer inverter? It is the main. There are many factors why we are considering this hybrid inverter here. First of all is reputation. This brand is here in the market for last 35 years. A person called Mr. Roland Studer has made this brand, and he's still with the brand as a chairman. And this particular inverter is in the market for from 2007, and this particular inverter is available here in India from 2011. There are many projects with a different application. It's installed here in India and worldwide. With this inverter, there are many things we can do. We can currently the scalability. The scalability, when I say, see, currently the customer is having a 24 kilowatt. Suppose the customer having a upgradation of the load later on one phase, so he can just add on one more inverter on the R phase or any of the phase the load is having, and that way he can scale the project. So there are many other different applications also. We can run this inverter completely off grid. Completely off grid means without any grid also you can use this inverter. If suppose at a place you have only one phase, and if you wanted to have a three phase output, this particular system can deliver from it can take the power single phase and it can give a three phase output. So that is also doable. And 100% unparalleled load. Unbalanced load is also possible with this inverter. So suppose in this particular inverter, one phase is having each phase is having 8 kilowatt of load, I mean inverter capacity. But still, if any of the phases also having a zero load also, it can run on the other two loads also. And if we can also add single phase generator as well, or three phase generator as well for a three phase output, and we can also have a single phase generator to give a three phase output. So in that situation, what happens is, if we are using one single phase generator in this particular R phase, so when the solar panel is not enough to charge the batteries, and the battery state of charge is going into a certain level, the inverter will give the command to the generator to start up, and it will start up taking the load in that phase and charging the batteries, and other phases will be charged from the battery itself. So in that phase, even if you're having a single phase also, so from one phase it can charge the battery, from from the battery it can give support to the other two phases. So that is why we have used this inverter. And the main thing, this design, see, low voltage design of this particular inverter is such that it is very safe to handle. That is the main point, because 48 voltage is considered as a safest voltage, and it is also having a galvanic isolation transformer inside the inverter. So in case of any surge or any situation from the input side, this transformer will isolate the load, so you will have a clear and safe output from the backup side. That is also a very good thing. So there are many topologies we can use this inverter for. There are projects running in India in several places as a microgrid as well. So if there is, suppose if there is a place there is no grid availabilities at all, so in that place maybe there will be a 50 or 100 small residential places are available. In that situation, we can use this inverter for to have a microgrid at the place. As it is a modular thing, it is a professional task to get it done perfectly. We have to have many parameters checked, and to doing this system, you should also have a support from the student team. Then only we can do it perfectly. Because in this particular project, we have used different kinds of cables for connecting the solar panels. We have used 4 square mm cables, and from AGB to the charge control, we have used 16 square mm cables, and from charge control to the fuse box, we have used 24 m square cables, and from the fuse box to the battery, we have used 95 m square cable. So everything is neatly done from my team. This thing, you have any query regarding a solar project, or if you have any concern, regarding uninterrupted power, please do reach to me and I will give you a solution. We are basically from Kerala, but we are willing to do projects anywhere in the world. We are going to commission this project soon. So like every connection is perfectly done. The remaining piece is missing is the connection between the batteries and the to the fuses. So once we establish the things, the everything will be powered up. So accordingly, we will do the commissioning and we will show you how. So we are proceeding with the commissioning procedures. So first we are going to switch on the batteries. So we have two packs here, 15 kilowatt hour, two batteries. We have a master and slave configuration in this one. The first battery will be the master and second will be the slave. So we have done all the paralleling connections in this rack mount setup, which came along with the battery. So we are going to switch on this. We are going to enable this connection, communication. And first of all, what we are going to do is we are switching on the first battery. When it is on, the second battery will also turn on, and we have to turn on the second battery also. So batteries are on, and the second procedure is we have to power the batteries through that fuse boxes. First, we are going to charge the fuse box of the charging controller. Please proceed this. So we are going to power the first charging controller. You can see that light turning on. Yeah, first charging controller is on, and likewise will be doing all the charging controllers. So when we are doing this, VT80 charging controllers will have a automatic setup to take the voltage. So this battery is running on 48 volt. So you can see that it is also working. Every charging controller, you can see it's working. Light is glowing. Light is glowing. Third one is also on. So this is the procedure. We have a fuse link here, fuse box here. Fourth one is also on. And after turning on this batteries, we have to check whether the data communication is properly happening. We have used this XCOM CAN communicator. So this will turn on when the inverters are on. And we can proceed with the inverter. First, R phase inverter. So you can, in R phase, we have two inverters. You can see both the inverters will turn on once we plug that on the R phase inverter. So this 48 volt system is safe to operate. That is why if it's a higher voltage system, will be a huge risk to handle these kind of operations. Yeah. Y phase is also on, and finally the B phase. Okay, all the inverters and the charge controllers are turned on, and the second procedure is we are going to turn on that AJB, array junction box of each charge controllers. Follow me, we will proceed that. So as you can see, these are the solar modules we have. It's a polycrystalline modules. We have 53 numbers of 335 watt peak and 385 watt peak. And the even polycrystalline itself, we have two capacities. And in there you are seeing is a monopore modules. Yes, that is of 550 watt peak capacity. So that is a 20 number. We have connected that to two charge controllers, and we have used the array junction box over there. And you can, as you can see, we have used a forge array junction box in here, and one array junction will have a 15 numbers of module, and the configuration will be 3 in series and 5 in parallel. You can see in this in the positive side and the negative side we have used um, fuses, and from the 5 in 1 out. So all the modules are interconnected with a 4 m square cable, and the out is going on a 16 m square cable. So if you can see that in that area we have constituted a small room. In that we have made that inverter installed. We have created a small portion, enclosed it, and we will be using a AC inside that cabin, so that inverter and the battery will be having a stable cool temperature. So the life of the battery and as well as the inverter will have a prolonged life. So that is why we have suggested to go with the AC in that cabin. So now we are going to disassemble disassemble this arrangement box, and we are going to power it on. Each one string will have three modules. So first one going, I'm going to turn on the all positive and the negatives. We have used a Cytel 220 watt DC SPD here, DC, and I'm going to turn this on. So the third charge controller is also on. This is a plywood wall, what you are seeing behind me, and behind this wall is the inverter we have arranged. As you can see, all the trunking and cables are laid in behind this plywood wall, and you can see that from the solar modules, from the arrangement boxes, the all cables are coming from through these pipes. How do I? Yeah, yeah. From the arrangement boxes, the cables are coming through these plumbing pipes, and and it is entering into this trunking cable. I mean, it's in the trunk, and it is going all the way, and it is entering to the charge controllers. And the red and black cable 25 m square, see what you are seeing is the output of the charge controller, and it is going back to the fuse boxes. And there are trunking trays for AC input and output separate. We have earth benches, two of them, both are AC, and we have cables lying down here, and we do have separate cables for trunking trays for um, separate. So we have separate trunking trays for communication cables as well. So this is what we have done here. So that is why our installation looks neat and clean. So everything looks fine, and everything is according to the stewardess instruction, because none of the cables are crossing. As per their instructions, AC and DC should not be crossed, and the data cable should be in a separate tray. So we have matched all the criterias. So this is how we done it. Okay. So and and every project we are doing something unique to match the requirement of the client. Actually, this is a this area this area is a separate portion. It's like just like this one, and it was we made into a separate room, and we are making a we install everything inside the room, and we are also placing an air conditioning just for the temperature to keep on the parameters. So we have completed the installation and the completion also. So now we are going to dress it. Once it is done, we will also have a cover, and there is a doors for future inspection and the services as well. So this is how we done it. Okay. When I'm turning it on, the color of the light will change. You can see all the lights are stable because all everything is on perfectly communicating. That is why. So I'm turning on the charging controller now. So charging controllers are on. Now I'm going to turn on the inverter. You can also see that there is a change in the lights. Now inverters are on. Now it is ready to power the loads.
There are different topologies and different methods how we can get to done a hybrid solar project. There are high voltage inverters, there are low voltage inverters, and in this particular inverter project, what we have used is a inverter from Switzerland. These inverters are a low voltage with a high frequency, and there will be a load. There will be galvanic isolation transformer on the load side, and there will be many other specialty why we are using this in particular inverter for. Why we are using this particular inverter here is because of the safety. Because low voltage inverters, any inverter which is working below 48 voltage will be considered as a safest voltage. So in this regard, this particular inverter is very safe, and there are many other specialty of this particular topology. Even we are using a lithium peroxide batteries. So in the low voltage systems, we will be normally paralleling the banks. So whenever a problem with one of the banks will be focused, but still the other pack can deliver the power. That is one of the main reasons of a main good thing about of having a low voltage systems. But when we are going with the high voltage system, the battery pack voltage will be on the higher side and the batteries will be on the series. So what happens is if any pack in the batteries will have any issues, so then the entire system will have an issue. So in the case of a breakdown, this topology is very good. So it will also, in case of any damage in the one pack, it will also give a power to all the other packs also.
So as we can see, the charging controllers and inverters are ready. All the lights are stable. So output is ready to deliver. So if you have any query, do let us know. We have these kind of projects coming up. So we are ready to do projects anywhere in the world. So this is Tudor and we are Le Helios. Thank you so much for watching. Everywhere in the world, power is going to be very expensive because the consumption is going to be very high every year. The same case is for Kerala too, because here in Kerala, about 22% of the total energy we consume is only generating from Kerala in the state only. So 78% of the energy we are consuming is procured from outside the state. And every year, as you know, the number of EVs are going high, and the number of electric device we are adding to our network is going to be very high. So what we personally believe is that every on-grid system should be converted to a hybrid system at one time. It is a trend actually. If you go look around the world, uh, self-sufficiency in terms of food and energy is a main thing. So this also come to a picture here in Kerala as well, because especially in Kerala, the total our generation is very low. So as you know, currently we do have a good policy, but as a number of systems are going high, probably it will be very difficult for the discom to provide this same policy for everyone. From the data, we understood that around only 1% of the total consumers have connected the uh, solar grid tie system right now, but still the grid is facing some issues. From the newspapers, I hope you understand. So that is why we ask the customer to go with the hybrid system. So if you wanted to have an uninterrupted power at your location, do let us know, and we will give you a tailor-made solution for you. Okay.